Greetings and welcome to episode 29 of the Sustaining the Herd podcast, brought to you by Agri-Services and Engineering of Raymond, Nebraska. I'm Andrew Wadle, and I'm in the studio today with my co-host, Brock Vitek.
Hey there, Andrew.
And we'd like to welcome back our past listeners. We really appreciate you joining us again today, and we welcome our new listeners. And for our new listeners, just a little bit about the Sustaining the Herd podcast. What we're going to do is we'll talk about really everything involving sustainability and animal agriculture, or really sustainability and agriculture in general. And so what does sustainability mean to Agri-Services? Well, it means protecting the air and water that we breathe. Everybody wants clean air and water. And it also, sustainability means productivity. It means doing more with less and getting the most out of our natural resources when it comes to producing our food and fiber. And then we have business sustainability. We have to have businesses that are successful and so that they want to continue to carry on. So business sustainability is a huge part of sustainability. So in all of our episodes, we will weave in and out of all these things, and hopefully it really gives you a good sense for everything that people in agriculture are doing to be sustainable. So with that, Brock, what do we got today?
Well, Andrew, we're going to change it up a bit. We do not have a guest today. However, I would like to talk about something that we've been observing and seeing in our work out in the industry lately. And for any of our returning listeners, you all are familiar with us talking about anaerobic digestion. So, Andrew, we've been seeing some issues with material settling in anaerobic digesters in our work lately. And you're an agricultural engineer who deals with these matters quite often in your day-to-day work. So I'd like to ask you some questions and just have a discussion here about some observations we've been able to make lately. Does that sound good?
Yeah, that sounds good, Brock. It definitely is something that's everybody who's operating in the anaerobic digester space. It's really a hot topic now, especially as these anaerobic digesters, they're starting to get some miles, so to speak, in the rearview mirror. And so the more digesters are running, the more time that passes, you start learning things, and issues emerge, and you see where improvements need to be made and whatnot. So yeah, this is a topic that really is a big thing right now.
Definitely, and I'll get to my first question here in a moment, but I'd like to call out all of the digester project developers and livestock producers who might be listening today. This is for you. If you have an AD project on your livestock operation or you're a developer, this is information that you might find valuable. So please take a listen.
Yeah, and there's a good chance that for some of you more senior people out there like me, you might remember back in high school the old Scared Straight videos, where you'd want to be a safe at driving cars because they'd show you the car crashes and it would kind of like scare you into driving safely. Well, this talking on this subject, sometimes this could be a scared straight moment for a lot of you, and that maybe this will get you right, or at least get you thinking about some things when it comes to the digesters.
Exactly. And when it comes to materials that settle in digesters, I think sand is the one that we see the most of. And some people might be wondering, where does sand come from? How does it even get to or into a digester? Could you talk about that, Andrew?
Yeah, sure. Well, sand can come from a number of different sources, and and so often we blame sand, and we always blame sand for settling. It's kind of like we always blame the electrician for a house fire when it could be the plumber's torch, And so when it comes to settling in digesters, we first look to sand, and really sand is used almost as a scapegoat, if you will, or a proxy for anything that will settle in a digester. And well, what can settle? Well, of course you have sand, and sand can have a number of different sources. And we can get into some of those. But in addition to sand, you can have coarse organic matter. Basic engineering physics would tell us that a small dense particle, like sand, and a large, not dense particle, like, say, undigested feed, they will settle at the same rate in a digester or any vessel. And so really what we're talking about is anything that could settle in a digester tank. Yeah, it could be organic matter, or it could be sand, or the other thing that's really overlooked is how much sand comes in the feed.
That's a good explanation. Thanks for teeing that up for us. So we now know where the sand comes from, or maybe some other settleable material. What are some of the challenges caused by settling in a digester?
Just before we dig into that, Brock, I want to just give some sense and some flavor for just what kind of quantities that we're talking about of sand. And so, back to this idea of always implicating sand, or even particularly bedding sand, there is a tremendous amount of grit in feed. I mean, if you were to look at on a per cow basis, if we were to look at say, just the amount of ash in feed, that alone could end up being more than the ash that would be contributable or attributable to, say, sand bypass from a sand separation system. So when you look at animal feed, animal feed could be as much as 6 to 20% of dry matter of an animal feed, and so that's a tremendous portion. And so as you're watching some kind of a forage harvester go across the field, and you see dust, let's say particularly haylage, where you've got these disc binds and they've got almost like operating under a negative pressure. They are sucking basically grit up in with the feed, and so we're talking about substantial quantities of grit from a number of sources.
And follow up to that, Andrew, when we think about settleable material, that's a tongue twister for me. I often think about maybe some finer particles like that dust, for example. We know that manure will contain kernels of corn sometimes that pass through the cow. Could a corn kernel settle out in the digester as well?
Absolutely. As I said previously, a large not dense particle, corn kernel, will settle the same as a small dense particle. So corn kernels, they are the ones that are some of the biggest would cause some of the biggest challenges. And boy, I tell you what, when you start looking at settled sand, you find out real fast on a particular day if a kernel processor was functioning properly and a forage harvester. Because if you have whole corn kernels, you've got a challenge. So when you look at a digester being cleaned out, or I'll say any tank being cleaned out that has settled material in, it almost looks like I refer to it as sand chowder. No one will look at soup again the same. So it's a mixture of sand and corn, right? Because it's the sand, and then it's the wannabe sand. And the wannabe sand is everything that wants to settle like sand.
That one might have to go on the list of all-time awesome Andrew quotes.
Yeah,
sand chowder. We're trademarking that right there. So, are there any other challenges we haven't talked about, Andrew, when it comes to settling?
Well, I mean, settling, it just goes on and on. It first starts in your process tanks. When it starts settling out in your process tanks, you start to have challenges. But at least in process tanks, you can get to them. Assuming open top process tanks, you can go into them with a mini excavator or your ramp down into them. But where you really start having problems is when you have sand settling in tanks, and it starts to get measured in terms of feet. And so feet as in depth of sand. And so now we start having a real problem. So as soon as you start having material settle, you start losing volume. And when you start losing volume, you start losing hydraulic retention time in an anaerobic digester. And so So you start losing hydraulic retention time. Now you start losing gas production.
It really compounds, and all of a sudden, your bottom line starts to show that. It
starts to show your bottom line, and so you lose it both on the revenue side because you're making less gas, and there's the potential for to really feel it on the operations and maintenance side. And I can't leave out process piping and things like that, because improperly designed systems, you're going to have problems in valves and fittings. Mm-hmm. Every place where you would have velocity decreases below a certain level, that's where you start to have.
I might also mention that any returning listeners would be familiar with the term VS, volatile solids, which we've often talked about as the fuel for anaerobic digestion, the food that the bugs eat. If you're shortening your hydraulic retention time, therefore reducing gas production, that means there's VS, fuel for methane production, that is being unused or potentially left on the table, probably passing through the system, right? And that could cause odor in your digestate as well. I mean, this could lead to neighbors maybe complaining about odor because your tank's filling up with sand. The implications go on and on and on.
The implications go on and on and on.
So enough about the challenges and maybe some of the negatives. What methods are there out there for handling settleable materials in anaerobic digestion systems? What are the solutions?
Yeah, well, really, this will be a real weaselly answer, but one of the biggest solutions is don't let it get into the tanks to begin with, because if you're having to solve it on the tank side, boy, that's when it starts getting expensive and really undesirable. And so the best thing that producers and operators can do is, and we're talking mostly right now about dairy, because that's where the vast majority, almost 100% of the digesters operating are in the dairy space, at least where grit and sand is a big concern. So really the biggest thing to do is to keep the settleables from getting in the digester to begin with, because once they get into the digester, that's when the challenges really happen, because now we need to go into an enclosed space, which is inherently dangerous, which we must avoid at all costs. That's where the problems really start. So we want to keep the sand and grit out of the digester. So really what that means is, we're talking about some kind of separation system. And here we're talking mostly about separation systems as they relate to dairy, because really dairy is where we would have higher proportions of grit because of sand bedding.
Sure.
And so we're looking at doing. So so what we want to do is we want to separate as much sand out up front. Mm-hmm. So, and just a little bit more about the magnitude of sand. And so, a dairy beds with somewhere in the neighborhood of 50 pounds of sand per cow per day, and so even if you were to assume a 2% sand bypass, a pound per day of sand starts to add up really fast when you start multiplying times a lot of days, times a lot of cows. Mm-hmm. And so it gets to be a huge number. But still, separation is the absolute way to go in order to try to minimize the challenges with respect to grit. But keeping in mind the fact that nothing is 100% efficient. Mm-hmm. 2% sand bypass would be considered best in class. And so those are kind of like the levels that we aspire to attain. But then again, keep in mind we might have 2% bypass, and we might bypass some proportion of the organic matter as well. And that,
sure. So you say separation is probably the key to the solutions here. What are the principles or the mechanisms of separation that we most commonly find coming in to save the day in these situations?
Yeah. So usually all forms of separation that are currently on the market today involve some kind of a settling type of operation. And so what that means is the manure is diluted in some fashion, and that potentially comes with some challenges, because with dilution you have to then potentially add add more heating. And so we dilute the manure so that we encourage the sand to settle. So we get the sand to settle where we want the sand to settle, which is outside of the digester tanks in a properly designed separation system. So these separation systems, they all rely on settling, but it's getting sand to settle in just the right place. There's also variations of separation where, say, a piece of equipment like hydrocyclones are used, which is really settling under high G's, not a centrifuge, but a hydrocyclone where you're settling under high G's. Whereas, of course, if you drop a particle in water, it's settling under 1 G, if you're for all of you remember your physics class. But if you spin something around in a circle, some kind of a circular motion, you impart more gravity to it, or more G's, and so that would encourage more fines to settle. And so usually the separation systems that you see on the market, there's some kind of gravity settling that may or may not be augmented with some kind of a hydrocyclone separation, which is some kind of a augmented separation under more force of G. Sure.
A moment ago, Andrew, you mentioned 2% sand bypass being, say, best in class in the industry. That would imply 98% sand recovery.
That's right.
When it comes to these separation systems you're describing, would you say that 98% sand recovery is pretty typical, or on average, what do we see on a dairy operation?
I would say that it is reasonably attainable, but it's reasonably attainable, but I'd say still best in class. We've measured some sand separation at 85%. Recovery, as in 15% bypass. That starts to get to be really, really big numbers, and so and that is something that we have the capability to do, is to look at a separation system and more or less do a mass balance around it and make an estimation where the sand is going, whether it's ending up in the sand pile, going back to be recycled, or whether it's ending up in the digester tank. Something else I forgot to mention, Brock. Is with all this talk about sand and digesters and whatnot, it's really, really important for digester developers and operators to remember sand killed digesters long before people bedded with sand. And so I want to mention this almost going back to the very beginning and saying the amount we in our industry, we grossly underestimate the amount of sand and grit that bypass or that's consumed by cows and then is excreted and goes into the manure. And so I'm going to bring that back to your other question, and that material tends to be a lot finer, right? So as I mentioned, the harvester going across the field and it's kicking up all this dust and it's getting sucked up and mashed into the feed. It's really, really fine. It's really, really fine. Very difficult to separate in a separation system. But then when you put it into a digester tank and it sits there for 21 days, 30 days at 100 degrees, you're creating these perfect. If you were something settleable, it's like the perfect place to settle, right? Because it's warm, viscosity is low, and these particles will want to settle.
Mm-hmm. Probably almost like pottery clay forming in the bottom of the tank, isn't it? Just that material packs together and it stays there.
Yeah, sometimes the finer stuff is more difficult to move once it's in place because there's just more surface area and it almost like locks together more.
Sure, it's not going anywhere.
It's not going anywhere.
I'd like to ask just briefly, Andrew. You mentioned that we'll come in and do like an audit of a sand separation system. What are just a few of the key things that you like to look for when you show up to a dairy and you're evaluating a system that might be having some sand bypass issues?
That's really a great question. And so, as I said, any separation process, after conveyance out of, say, some kind of reception tank, it's diluted. And it needs to be diluted to the extent that the sand grains want to settle. In other words, you break the viscosity up to a point a sand grain can escape, so to speak, and go to the bottom. So if that water used for dilution is already very viscous to begin with, you can't dilute manure with manure, is what we like to say.
Sure.
And so the very first thing that I would be looking at is what's the quality of that dilution water. And for dilution water quality, we usually use total solids, but as an industry, we generally use total solids as a proxy for viscosity, because most often those track pretty well together. Higher total solids, the higher viscosity.
Sure.
The higher viscosity, the poorer the quality of the diluent. Cold, clear water, if you could use it, would be great, but most often we can't. However, what we can do is we can always be augmenting our recycled water with, say, milking parlor, washdown water, gray water. That's the cleanest dirty water on an operation.
Dilution is the solution to the pollution.
That's right. That is absolutely right.
You taught me that one. It's a fun
That's
little
the
rhyme there.
Old environmental engineers credo, but still it is true. So that's really the first thing that we look at. Is it all starts with, before you look at whether any equipment, whether it's a mechanical system or a sand lane system, before you even look at those things, if the manure is not being diluted adequately, you're really in trouble. That's where we'd like to start.
Yeah, that'll make sense. So when it comes to separation systems, as good and as effective as they may be, they probably have some limitations, if I had to guess. What are those practical limitations?
Yeah. Yep. And so I'm going to go back to another. I'll say, if you don't mind, talk about sand recovery. I'll call it a sand recovery myth, so to speak. And this is an area where people, developers, are often lulled into a false sense of security in that, say, a separation system is performing beyond their wildest dreams, because the producer will say, "I haven't bought sand in a year." Okay, well, that says that your separation system was 100% efficient. There is nothing that's 100% efficient. Absolutely nothing.
Maybe you're not bedding with enough sand either.
Well, but it's not so much that as much it is, just like you don't recapture all the sand, you don't exclude all the organic matter, right?
Sure.
And so we have a situation where, we're recovering a whole lot of sand, but yet we're also retaining a little bit of organic matter.
Mm-hmm.
And so at the end of the day, on a mass or a volume basis, it's quite possible over the course of a year you're not buying any sand. But it's not because you captured every single, on December 31st, you don't have every single sand grain that you had on January 1st, is what I'm saying. But what has happened is you've lost some sand, but you've also retained some organic matter. And so the net on a volume or even a mass basis, you're in the same place. But it's that sand bypass piece. That's the part that we need to be concerned about.
Sure. And I imagine, this is another conversation, maybe another episode, actually. Maybe substituting some sand or some organic matter for sand could present some cow health issues as well, right? If we're retaining organic matter in our bedding.
Oh, absolutely, Brock. You certainly understand biology, and what organic matter does and what it does as it relates to mastitis and whatnot. And so, every bit of organic matter you retain, you diminish the quality of that bedding sand to some degree. So we can't be saying rah, rah, rah. We have the same amount we started with, but we backfilled our bypass sand with organic matter. That's not necessarily the greatest thing. It's not a total win.
Mm-hmm. Another notable Andrew quote: "Cows are mothers, and milk is food. They need a clean, sanitary environment."
Absolutely. Yep. That's absolutely right.
Sure. Any other thoughts on separation, or I'd like to switch gears a little bit?
No, I think I just one other thing for developers and producers. either with digesters and sand or planning for digesters and sand. Another key aspect, I always start on the input side, because if you don't get it right on the input side, we can't expect the process equipment or the engineers to pull the rabbit out of the hat to make it work. And so, if you want to have a successful system, it all starts with two things. First, it starts with the right sand. And the right sand is some kind of a washed product. And a washed product, by its definition, by its nature, by its specification, it's a settled product. And so you have a material that's settleable. So usually what that means is a concrete sand. And concrete sand, it can be an exact state specification sand, or it can be a non-specification. But, sand that goes in a concrete has a certain size to give concrete strength and whatnot. And so, and it's a very, very well-defined size range. It just so happens it's a really good sand for cows. When you look at the size of it, from a cow comfort standpoint, it's very suitable, and it's also very suitable from the size standpoint. It contains a lot of product, a lot of material that's very, very settleable. And then the other piece, going back to the water quality and sand type are just the two big hitters for ensuring a separation system is going to be successful, or at least getting yourself on the right track.
And that's all fine and dandy as long as we have a system in place for that sand to settle out and be separated out before it gets to the digester, or it'll settle out there.
You have to have the system, and you have to have the system that's managed accordingly. And that's
going to settle. You decide where.
And and the more you capture upfront in a system, the better off, because otherwise it is like a sand rodeo. You are attempting to round it up everywhere, but it's always better before the digester, outside of the digester, as opposed to, right on down the line.
Awesome. So Andrew, throughout the conversation, you've talked about mixing in a digester, and you've talked about agitation of manure. Some people might think mixing and agitation are synonymous. I don't believe they are. Could you explain mixing versus agitation for us? Because these are common terms that we see in the AD world.
Yeah, and I think I can make a distinction between the two, and I can't say that it's any in engineering or process engineering that there's been any well-defined definition of these two, but mixing is in my view is really a process by which you're trying to get all of the particles to come in contact with one another. It's kind of like when you host a party, right? You go into the party and you say, "Hey, Brock, meet this person." And I say, "This person, meet this person." I want everybody to have contact with one another, right? Well, that's mixing, Agitation is this process where instead of just gently causing all the parties and particles to come together, it's where we are using high energy, high velocity in hopes of keeping particles suspended. Now, what happens in the case of agitation is, you look underneath an agitator. Where are the biggest piles of sand? A big prop agitator. The biggest piles of sand are right underneath the agitator, and part of this is because we're going to go real engineered now, in that manure is what manure when it's viscous, it's what we in engineering called thixotropic. Salad dressing is thixotropic. Tomato ketchup is thixotropic, and so when you look at ketchup in a bottle, it's just like a blob, right? You can turn it up and turn it down and turn it up and turn it down, and it just kind of wants to stay in the bottom. You give it a good vigorous shake, right? And that ketchup, it just wants to slide up and down the sides and do its thing. And so by that example, hopefully maybe you get a feel for what thixotropy is, and that is the more you shear it, the lower the viscosity goes. Okay? Again, salad dressing, ketchup would be two really good examples of that. And then and manure. And so what happens is we agitate, and we think we're doing a great job because this stuff is swirling around, and But meanwhile, really what we're doing is we're really just adding enough shear to drop the viscosity that, yeah, some of the particles are carried up, moved along, but we're also dropping the viscosity because we're shearing this material so hard that we're actually causing sand to settle. And so a lot of times what we want to do is focus more on mixing than agitation. And this is definitely an area where as an industry we will continue to learn and continue to develop design parameters for these things.
Sure. Yeah, you talk about that. We'll continue to learn and develop some things with mixing and agitation. I'd like to jump back to grit, and sand handling in general, and think back to our separation discussion here. What is the future for grit and sand handling? Just packaging this whole conversation up today. Where are we headed, Andrew?
I see it going in three different directions. So, and I'd like to call, and maybe all three are what the answer. I do think all three end up being the ultimate solution. The first would be there's more that can be done on the front end with equipment to do separation. Again, we're going to assume that you have the proper quality water, and we're going to assume that you have the proper management. But so when you look at sand and gravel processing, they have the same problems as dairies and digesters do. They don't want to fill ponds with fines. Why? Because they're difficult to dispose of. They're difficult to get out. They're all these things. And so in the sand and gravel industry, they do sand separation much, much, much finer than what we are doing today. And so it's really a matter of companies bringing more of that technology into the arena, because there is a technical solution to improving sand and grit recovery. And I'm going to keep on coming back to the term grit, because remember, or settleables, because this can mean a whole lot of things. We're pretty deep into developing or designing systems for feedlots. It's not bedding sand; it's grit. It's that is below sand or grit that comes off of concrete or comes off of fields. And so we're talking about some really, really fine material. But yes, there are solutions to capturing this fine material. So that's the one thing. The second thing is, so that's getting the sand out ahead of time. Then let's look at in the tanks. And so there's a company right now that's cleaning tanks with robots. And so you're almost on a maintenance plan. So you're saying, hey, we know we're going to have this stuff settle out. It's going to happen, right? Because grit killed digesters before there was any sand bedding on dairies. So we know we're going to have grit settling. And so we're going to get on a contract basis. We're just going to clean our tanks, without taking them down on X interval. Mm-hmm. And so we're going to get it before it gets us. Yeah. And the third thing is that, and there are companies doing this as well, and that is, how do we remove grit from tanks in real time as a matter of a digester process? In other words, built-in cleaning systems, so that we're always just slowly removing that material out of tanks. So I think those are the three things: getting more out to begin with, and then and then the second thing would be the robot go into the tank to clean it out on a regular basis. The technology's there. It's just a matter of you got to use it. And then what can we have for technology to mine the sand off the bottom of the tank in real time? So I think it's going to come along. We're still, on the development curve for digesters. If you think of a development curve for any product of being the toe, the ankle, the shin, and the knee, we're somewhere over the ankle, and so the more of these systems that are going to go in right now, we're going to there's going to be a lot of development and a lot of opportunity to get better in this area.
Certainly. Well, Andrew, this has been a fun conversation, and we've been seeing these issues quite a bit in our work lately. And for all of our listeners, I hope that you find some value in this conversation. Whether you're a livestock producer, whether you're a project developer, or whether you're someone from town, as we say, who's a consumer of agricultural products, this is something that ultimately impacts all of us. And if you are a producer, livestock producer, or a developer specifically with an AD project where this is of concern, feel free to reach out to us. We're always happy to have a conversation and help you try to figure out what may be going on with your system, or maybe try to prevent some of these issues like Andrew talked about today.
Yeah, and that's right, Brock. And for the people in town, it would be really, you'd be very encouraged to know what dairy producers do to keep cows comfortable when it comes to using sand bedding, and then the challenges that it poses throughout in their operation. And they do it for one reason. They do it to take care of the mothers and to take care of the cows that are producing milk, to keep them healthy. And so for any dairy producer, it's keeping the cows clean and comfortable and producing first. And then the digester becomes, of secondary importance, but they're always going to take care of the cows first. And they do that with sand bedding, and then deal with the sand part later.
It's worth the downstream headache to do the right thing up front.
Amen to that.
And, just one final comment, Andrew. You've had many quote-worthy statements throughout this conversation, but I think my biggest takeaway is that this is not your first sand rodeo.
This is not. Hey, there you go, Brock.
So we'll leave it with that one there, folks.
Oh.
And we would like to thank all of our listeners for choosing to spend some time with us today. And we look forward to being back with you again, as always, in a couple of weeks. Until then, thanks for joining the herd today.